Hello everyone and welcome to Infinity Learn by Sri Chaitanya, and I am Ravindram, and today I am going to discuss the solution of LTC MPL physics paper weekend test 13. Okay, so let's quickly begin with the first question. The equation of a wave is given by zero point 0.5 sine omega t plus kx. Okay, so everything is given here. So what they are asking is the ratio of maximum particle velocity to wave velocity. Now what is the maximum particle velocity? It is amplitude into omega. So it will be zero point 0.5 into what is omega? Omega, as we can see, is this omega t plus kx, right? So omega is 100. So this is gonna be 50. And what about the wave velocity? See, wave velocity, we know this thing that omega is 100, k is 25, and k is also known as omega by v. So wave speed is omega upon k, right? It is, sorry, k is 25. Okay, so it will be 100 by 25, which is equals to 4. So we have vp and v. So what do they need is vp upon v. So it is gonna be 50 upon 4, which is 12.5. So first option is correct. I hope you understand. Now second, when a transverse wave is reflected from a rigid wall, always remember, suppose a wave is going like this and this is a rigid wall. After reflection from this rigid wall, it goes back like this. Okay, and it suffers a phase difference of, sorry, it suffers a phase difference of pi, right? Okay, now third is, if you set up seventh harmonic on a string fixed at both ends. Fixed at both ends means, and n is equals to 7 is seventh harmonic. 1 2 3 4 5 6 7. How many antinodes? 1 2 3 4 5 6 7 antinodes, and nodes are 1 2 3 4 5 6 7 and 8. So nodes are 8, antinodes are 7. The temperature at which the speed of the sound in air becomes double. See, speed of sound, what is the formula? Gamma RT by M naught, right? So V is inversely directly proportional to root over temperature. So initial temperature is 273 Kelvin, and if velocity needs to be doubled, so we will say like this: V upon 2V is equals to root over T initial upon T final. So T final is technically 4 times T initial, which is 4 into 273 Kelvin, right? The thing is, here temperature should always be in Kelvin, cannot be used as degree Celsius, right? So even if the temperature is given in degree Celsius in the question, you have to convert it into Kelvin. The velocity of sound is measured in hydrogen and oxygen. Okay, hydrogen and oxygen both are diatomic gases, so both have gamma values same. Okay, so gamma for hydrogen is equals to gamma for oxygen, so there is no doubt about it. So when you take the ratio, so it will become, okay, it will become under root gamma RT by M naught. Temperature is same, so it is molecular mass of oxygen upon molecular mass of hydrogen. So it is 32 upon 2 under root is 4 is to 1. The equation of a stationary wave is, stationary wave equation is given the separation between two consecutive nodes. See, when I talk about two consecutive nodes, the distance is always lambda by 2. Now this is k. This is what k. So you can say k is 2 pi by lambda is equals to pi by 20. So from here lambda by 2 is equals to 20 centimeter. In a stationary wave, see, whenever I talk about a stationary wave, suppose this is a stationary wave in its third harmonic, right? So what happens if I talk about the particles here? These particles are together going up and they all are in same phase, right? But the particles here are together going down and all of them are in same phase, and the particles here are again going up and all of them are in same phase, right? So whenever you pick up on the particles on either side of the node, they vibrate not in same phase but in opposite phase of phase difference pi. That means if I'm talking about this and this particle, right? A and B, they are in opposite phase. But if I talk about two particles A and suppose C, so they are they are between two consecutive nodes, right? So obviously they will vibrate in the same phase. So second option is correct. Second is correct. No need to read third and fourth option. Even if you want, you can see in region between two antinodes vibrate. No, between two antinodes, they can be anything. Either they can be in same phase or different phase. So wrong. Same medium vibrate, wrong. Okay. Length of a string tied to two rigid support is 40 centimeter. So length is given 40 centimeter. Maximum wavelength. See, maximum wavelength for stationary wave to establish. What is the condition here? For stationary wave to establish, the condition is n lambda by 2. So what is lambda? 2l upon n. So if you want lambda to be maximum, n should be minimum. So minimum value of n is 1. So 2 into l by 1. So answer is 2 into 40, which is equals to 80 centimeter, right? Uniform. This is a very common formula. Speed is root over t by mu, and sometimes we express mu as rho into a. So this is your option. Fourth. Velocity of sound. Okay, sound travels faster on hot summer day than a cold winter day. Okay. Velocity of sound is proportional to the square of its absolute temperature. No, no, not directly proportional. Inversely. So second statement is false. That means third option is correct. Speed of sound waves in a fluid depends upon, see, longitudinal waves, the speed is b by rho under root. So square root of bulk modulus of medium. Fourth option is correct. Electric field and potential. There's a simple relationship. Electric field is delta V upon delta R. So what is delta R? It is delta V upon electric field. What is delta V? 0.5. What is electric field? 100. So it is 5 by 1000. That is 5 millimeter, right? So charges are given 1, 2, 3, 4. Now potential is a scalar quantity, right? So at the center they want, so a is given root 2, and what is this distance? Let's say this distance is r. So r is root 2a by 2. Okay, so r is technically a by root 2, and a is root 2. So root 2 upon root 2 is 1, right? We know that this diagonal is root 2a. Suppose if this is a, this is a, this is what? Root 2a. So obviously this distance will be half of it. That is why I said it like this. Next is, okay, this is plus 10 microcoulombs, this is plus 5 microcoulombs, this is minus 3 microcoulombs, and this is plus 8 microcoulombs. What will you do? You will say potential is kq1 by, distance is same for everyone, kq2 by r plus kq3 by r plus kq4 by r. So what you need to do is kq by r, take out common, add all the charges and put the value of k and r. That's it. Yes or no? R is 1. So simple. When one electron is taken towards another electron, see, whenever we talk about the potential energy of the system, whether it will increase or decrease, just remember, whenever we are going against the internal force of the system or the conservative force of the system, then potential energy increases. If we going towards the conservative force, then it is reducing. For example, these two electrons, they naturally want to go away from each other. They naturally want to go away from each other. So if you are taking one electron away from another electron, potential energy will decrease, no doubt. But if you are taking one electron towards another electron, then potential energy definitely will increase because you are going against the natural force between them, right? So which option is correct? When one electron is taken towards, that means we are talking about this green one, so obviously increases. Kinetic energy of an electron accelerated through a potential difference of 100 volts is, kinetic energy is q into v. So 1.6 into 10 to the power minus 19 is the charge of an electron into 100 volts. So energy will be 1.6 into 10 to the power minus 17. First option correct. Inside a hollow charge sphere, we all know that if you take a hollow sphere uniformly charged on the surface becomes equipotential and the electric field inside is zero, as so the volume, so the potential is constant. Got it? So potential inside is constant, electric field inside is zero. The area of the plate. Okay, suppose you take two capacitors, one with a lesser area, one with a greater area. We are concerned only with the areas which are superimposing. Okay, that's it. So technically here also we will consider A2 only. So epsilon naught A by D, in this A2 will be the answer, right? The charge stored in a capacitor is 20 microcoulombs. Okay, charge is given 20 microcoulombs. Potential is given 500 volts. So what is the capacitance? Q by V. That's all, right? I hope you can do it. 20 by 500. 1 by 25.04 microfarad, right? When two capacitors, one of 3 microfarad and other 6 are connected in series, the combination of the charge potential difference is, and the combination is charged to a potential difference of 120 volt, the potential difference across C. Simple concept. This, this. Either you go with some logic or you go with the concept I'm going to tell you now. See, either what you can do is you can say, sir, it's very easy that the charge on the capacitor Q and minus Q, the charges will be same, they are in series. Okay, so what you can do is Q is equals to C equivalent into V. You can find C equivalent. How will you find C equivalent? 1 by C equivalent is equals to 1 by C1 plus 1 by C2, like this. And once you know charge, then V1 will be QC, sorry, then V1 will be Q by C1. Got it? This is how you can get the answer. Otherwise, since we know that Q is constant, Q is equals to CV. So obviously Q is constant, right? Q is constant in both the capacitors. So greater the capacitance, lesser the potential. That means C is inversely proportional to V. C is inversely proportional to V, or we can also say that V is inversely proportional to C, right? So we can say V1 is equals to C2 upon C1 plus C2 into total potential drop. So C2 is what? 6 upon 9 into 120. 3 2s are 3 3s are 3 1s are 3 40s are. So V1 is 80 volts. Got it? Either you can go like this. Now obviously this is, let's say P is the positive plate. So from P how many plates are coming? See, this is positive, this positive, this is positive, and from Q negative, 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 and negative. 5 plates are coming from P, 5 plates are coming from Q. 1 2 3 4 and 5, like this. Positively charged, positively charged, positively charged, positively charged, positively charged. Which is the plate? Plate number 1. This is what? Plate number 3, plate number 4, and plate number 5, and plate number 6. Now like this, this is Q. So what are these plates? In front of 1 you have minus, 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 and minus. In front of 1 we have 2. In front of 3 we have 2 again. Okay, and in front of 4, so 6 is negative. Anyways, all of these are in parallel, so no need to worry, right? This is 3, so 3 has 2 ends, right? Then 5 has 2 ends. Now in front of 3 there is 2, and in front of 3 there is 4, right? And in front of 5 there is 4, and in front of 6 also there is, and in front of 5 there is 6 also. Okay, got it. So what are these are the plates, like this they are arranged, shown here, but diagrammatically it is shown like this. So 1 2 3 4 5, all 5 are in parallel. So you will say if capacitance of single is C, so C equivalent in parallel they will be added to 5C. So 5 epsilon naught A by D. 21. Two capacitors of capacitances 3 and 6 are charged to a potential difference 12 volt each. They are now connected. Okay, they are now connected to each other with positive. See, it's simple logic like this. If they are connected, normally the common potential formula is C1 V1 plus C2 V2 upon C1 plus C2. But the thing is, if they are connected like this with opposite polarities, then instead of C1 V1 plus C2 V2, we take it C1 V1 minus C2 V2, right? That's all. So what is C1? 6 into 12 minus 3 into 12 upon 6 plus 3. So it will be 36 by 9. Answer is 4 volts. I have told this in the class itself. This example also we did in the class, right? Not exactly, the data is not same, but this kind of a question we have already done in the class. So capacitor of capacitance C has charge Q, stored energy W. C. So W is equals to Q square by 2C. So obviously if you make it 2Q whole square by 2C, it is going to become 4 times Q square by 2C. Right? That is 4 times W. Got it? The ratio of the resultant capacities when 3 are okay. When they are connected in series, then 1 by 2 plus 1 by 4 plus 1 by 6. For this, definitely you will find out that answer is 1 microfarad, right? And simple, you can do it. See, 1 by 2. So it is what? 6 plus 3 plus 2. Oops. It is what? Where it is, yes. So it is 12 and it is 1 6 sorry 2 6 are 4 3s are 6 2s are, right? 6 plus 3 9 plus 2 11. So C equivalent is 12 upon 11 microfarad, and when they are in parallel, then equivalent will be 2 plus 4 plus 6, right? 2 plus 4 plus 6, what is this? This is 12 microfarad. So if you want to take the ratio C equivalent upon C equivalent dash, let's say, so it is 12 upon 11 upon 12 is to 1. So answer will be 1 is to 11. Got it? Now everybody knows that Q by epsilon naught is the flux through the complete cube, and the flux is equally divided in 6 phases. So flux through a single phase will be 1 by 6 times the total flux, that is 1 by 6 into Q by epsilon naught. Now inward and outward flux, see, we say that net flux is equals to total charge upon epsilon naught. So inward flux will be taken negative and outward flux will be taken as positive. So it is minus 8 into 10 to the power 3 plus 4 into 10 to the power 3 into epsilon naught is equals to Q inside. Got it? This was a very easy paper, very easy paper. See, we know this formula already. This is electric field and this is dipole and this is angle theta. We say that torque is equals to vector P cross vector E. So tau is equals to PE sine of theta. I guess everything is given. Torque is given, right? Torque is given. Okay. P is equals to Q into R. So R is given, the distance between them. Electric field is given. Electric field is also given. And theta is given, right? So all these things are given. Only Q needs to be found out. So I guess you can do this using the formula. So there is no doubt in it, right? It's quite easy. Now again, we need to find out the dipole moment. See, We will say that there are two dipoles actually here. One is this q into a, another will be q into a, and it is 60 degrees. So when two vectors, these are vectors, right? When two vectors are equal in magnitude and are acting at an angle of 60 degrees, then resultant is always root 3 times. Okay, so this is your net dipole moment. Got it? Now let's come to question number 28. A dipole is placed parallel to electric field, right? This is vector p and this is vector e. So what is the work done? The work done in rotating the dipole by 60 degrees is, see, work done is PE cos theta 1 minus cos theta 2, right? So P into E, cos theta 1 is 0 degrees. So cos 0 minus cos of 60 degrees. Cos 60 is half. So work done is PE by 2. So technically PE is 2W, right? Now what they are asking is work done in rotating it by 180 degrees. So PE cos of 0 degrees, because initially they are parallel, finally they are anti-parallel. So cos of 180 degrees, cos 180 is minus 1, so it is 2 PE. PE is 2W, so 2 into 2W, answer is 4W. You understand? A vessel of linear coefficient of expansion A. So a vessel, so alpha of the vessel is A, is half filled. Okay, so let's say instead of vessel, let's use the word glass. Not glass, container. Let's use the word container. Okay, so alpha of the container is A and volume of the container is V, right? On increasing the, is filled with half liquid. Acha. So volume of the liquid is V by 2. Do we know alpha of the liquid? No. Fine. So what they are asking is, if the volume of the empty space remains same, whenever it is a question like this, always remember V1 gamma 1 is equals to V2 gamma 2, whenever the volume of the empty space remains constant. Okay, so we will use this logic and say that Vc into gamma c will be equals to Vl into gamma l. So Vc is V, gamma c is 3 alpha c is equals to V by 2 into gamma of the liquid. So we can say gamma of the liquid is 6 into alpha c, that is 6 into A. Do you understand? A vessel is half filled with liquid at 0 degrees centigrade. Then the vessel is heated to 100 degrees centigrade. Okay. So what is initial volume? It is V by 2. What is final volume? 3V by 2. Coefficient of apparent expansion. It is relative change in volume upon actual relative volume initially into 1 by delta T, right? So gamma apparent will be 3V by 4 minus V by 2 upon V by 2 into 1 by 100. So it is 1 by 4 upon 1 by 2 is 1 by 200. So it will be 1 by 200, that is 0.005. Do you understand? 0.005 per degree centigrade. Third option is correct. Got it? Now 31. The coefficient of real expansion of mercury is this. Given. The density of the mercury is given. Density of the mercury initially is given. What is density is 573 Kelvin. Okay. So what is the formula? See, we generally say that rho is equals to rho naught upon 1 plus gamma delta T. But approximately we can use binomial expansion and say it is 1 minus gamma delta T. Now everything is given. So density initially is 0.18 into 10 to the power minus 3 into 1 minus gamma is given. What is gamma? Gamma is given, oh sorry, Density is 13.6. I'm so sorry. That is gamma, right? Huh. It is, it is 13.6. 1 minus 0.18 into 10 to the power minus 3 into delta T will be C 573 Kelvin and 0 degree Celsius. Very carefully. T final is 573 Kelvin. T initial is 273 Kelvin. So delta T is how much? 300 Kelvin. Now put it here 300. Right. Now you solve it, you will definitely get the answer 12.9. Got it? See, for water, we know what happens. For water, the graph of its volume is versus temperature is like this. Okay, so volume falls up to the 4 degree centigrade point. After this, the volume starts increasing. So first decreases and then increases. It is anomalous behavior of water, right? 33. A glass flask is filled up to a mark of 50 centimeter cube of mercury. Okay, so change in volume is what? See, a glass is filled up to, so that is what we need to figure out. Okay, let's do it. A glass flask is filled up to a mark of 50 centimeter cube of mercury at 18 degrees centigrade. If the flask and the contents are heated to 38 degrees centigrade, how much mercury will be above the mark? See, gamma apparent is equals to delta V by V relatively into 1 by delta T. And what is gamma apparent? Gamma apparent is gamma of the liquid minus gamma of the container, right? Now, what is gamma of the liquid? Have they given anything? Alpha of the acha, okay, gamma of the liquid is given. This is 180 into 10 to the power minus 6 minus gamma of the container is 3 times alpha of the container. Alpha of the container is this 9. Okay, so you put the value I have told you. So gamma of the container is 3 into 9 into 10 to the power minus 6. Okay, so 9 threes are 27. Whatever it is, you put the values, you put the data and solve the question. You'll get the answer from here. Okay, is it clear? So once you know the value of gamma A, just put it here and get the value of delta V. The initial volume is given 50 centimeter cube. Now moving on to the next point. A cylindrical container of volume V is completely filled with a liquid having coefficient of volume expansion gamma. So gamma, okay. If the level of the liquid does not change on heating, then coefficient of linear expansion of the material of the conductor is C. Again, same concept. V1 gamma 1 is equals to V2 gamma 2, or you can say VL gamma L is equals to VC gamma C. They are saying that the level of the liquid doesn't change, right? So volumes are same. So we can say volume is same because it is completely filled. So gamma of the container is gamma of the liquid, right? And they're asking you alpha of the container. So we can say 3 times alpha of the container is gamma of the liquid. So alpha of the container is gamma of the liquid by 3. That is gamma by 3, right? Okay, so YouTube container. So they are technically saying that the volume of mercury at 100 at 0 degree centigrade is 60 into area, and volume of the mercury at 100 degree centigrade, this is at 0 degree centigrade, and at 100 degree centigrade is 62 into A. The coefficient of volume expansion C, gamma L, again same thing, delta V by V into 1 by delta T. So 62 minus 60, that is 2 into A. Original is 60 into A. Change in temperature is 100. Got it? Fourth option will be the right answer. Now here we need to figure out that, see, it's a hydrogen gas. Hydrogen is diatomic, and what is gamma? Gamma for this is not expand coefficient of expansion. Gamma is the ratio Cp by Cv, right? So this is what 1 plus 2 by degree of freedom. Degree of freedom for hydrogen gas is, it's diatomic. So for a diatomic gas, degree of freedom is 5. So 1 plus 2 by 5 is what? This is 7 by 5. And for next is helium, right? Helium is a monatomic gas, right? So gamma for helium will be 1 plus 2 by F. Degree of freedom for monatomic gas is 3. So answer is 4 by 3. Now, what is the molecular mass of hydrogen? You will say, sir, it is 2 grams. Molecular mass of helium will be what? 4 grams. Okay, helium gas. And temperature also. So what is the temperature for hydrogen gas? It is 300 Kelvin. And what is temperature for helium? It is 400 Kelvin. So you know everything. So you'll say velocity for hydrogen, velocity of sound in hydrogen upon velocity of sound in helium will be 1 by root over gamma of hydrogen into temperature for hydrogen upon molecular mass of hydrogen. R will get cancelled upon gamma for helium into temperature for helium into molecular mass for helium. Now you put everything carefully here and you will definitely get the right answer. No doubt about it. Clear? Both option will come out. Now a string is given. So length is given 7 meter. Mass is given, okay, 0.035 kg. Tension is also given. Oh, so what else you need? Formula is very simple. T by root over mu. What is mu? Mass per unit length. Put the values, get the answer, right? Just put it. 60.5 into 7 upon 0.035, right? Put it, get your answer, okay? Now, the resultant amplitude of a vibrating particle by superposition will be, see, resultant amplitude is always a1 square plus a2 square plus 2a1 a2 cos of delta phi whole to the power 1 by 2, right? So we will say amplitude will be a square plus 2a square. Delta phi will be what? Pi by 3. Pi by 3. Now cos 60 degrees is half, right? So it will become 2a square plus 2a square into half whole to the power 1 by 2. It is root 3a. Got it? 39. Again same thing. See here, k is what? Pi by 15 is 2 pi by lambda. So what is lambda by 2? Lambda by 2 is 15 centimeter. That means if you start from here, this is x is equals to 0 and this is x is equals to 15 centimeter, right? So what will happen? The wave will be formed like this. Yes or no? So the particles here will be going up, the particles here will be going down. So they will have a phase difference of pi. Now they are talking about two particles. One is at x is equals to 13 here and another one is x is equals to 16, which is here. So they are not, they are adjacent, they are in the adjacent segments. Okay, that means on the different sides of a single node. So whenever we are talking about particles on two different sides of a single node, then obviously they will have a phase difference pi. I have already discussed this in today's lecture only. Now this is very simple. What is electric field? Electric field is minus del V by del X. So it is minus differentiation of 3x square is 6x. So electric field is minus 6x. Okay, and x is equals to 1. So answer is minus 6. Now this is simple. 8. So small drops have got potential. Small drops have got potential 10 volts. Right. How many drops are there? 8. So by volume conservation we will say that, and every charge, every drop contains the charge q, let's say, right? Every single drop, this we are talking about a single drop. Now let's move ahead. According to volume conservation, if they contribute, if they coils to form a bigger drop, so it will be 8 into 4 by 3 pi into small r cube must be equal to 4 by 3 pi into capital R cube. So from here capital R will be equals to twice of small r. Now what is the small v? K q by r, small v. Okay, that's potential of a single charge. Now for the bigger drop, total charge is 8q and radius is 2r. So potential will be K into 8q upon 2r, that is 4 times kq by r, and kq by r is actually 10 volts. Got it? So overall potential will be 40 volts. 42. This is very simple. Two equal charges q are placed at a distance 2a from a third charge minus 2q placed at the midpoint. So q and minus 2q. This is A. This is A. So potential energy, we will have to form three pairs. So one will be this pair, another will be this pair, and the last one will be this pair. Can you see that? So let's write down. Total potential energy will be K into Q square upon 2A plus K into Q into minus 2Q. So I'll write with the respective color so that you can understand, right? When I talk about red is minus kq, sorry, plus kq into minus 2q upon a. Now one more is with yellow, right? Plus k into minus 2q into q upon a again. Now you can add them and get the result. So what is the answer? Okay, kq square by a common, kq square by a common, and then it is half. Minus 2 is 4, so 1 by 2 minus 4, 4 to 8 minus 1 is 7, so minus 7kq square by 2a. Now put the values, right? I guess third option is matching. Clear? 43. So two unlike charges q and minus q are placed. Obviously vector scale, sorry, potential is a scalar quantity, so if these distances are same, the potential here will be kq by a plus k into minus q by a. It will be 0. Got it? 44. See, a charged particle is shot towards, so this is capital Q which is fixed. So if it is shot from infinity where its kinetic energy is 0 and its potential energy is 0, so obviously if it is short, sorry, not 0, suppose it is short with a kinetic energy of what, half mv square, so it will reaches to this point where its velocity and kinetic energy becomes 0 but potential energy becomes k q q by r. So we will use the conservation of energy. Since there is no external force, so whatever kinetic and potential are here at infinity must be equal to kinetic and potential at the closest point of approach, right? So from here we can say that 0 plus kq by r is equals to half mv square plus 0 at potential, 0 at infinity, right? So we can say that kq by r is equals to half mv square, right? So from here we can say v square is inversely proportional to r. So they are saying r is inversely proportional, sorry, r is inversely proportional to v square. So if the speed is doubled, so r upon r dash is equals to 2v upon v whole square. So r dash will be r by 4. So if the speed is doubled, obviously the distance will be 1/4. Logical, na? R is inversely proportional to v square. So if you double the speed, r will be 1/4. 45 here. Again, same thing. Very simple question. What is the charge on 6 microfarad capacitance? Here, what is the charge? So obviously, first of all, what you do is find out the C equivalent. So these two are in 6 and 12 are in parallel. So it will be 6 plus 12, that is 18 microcoulombs. You know this? Okay. Now we can say that it is 9 microcoulombs and 18. So what is the final C equivalent? It will be, I'll have to write it like this only, 1 by C equivalent final. 1 by 9 plus 1 by 18, that is 3 by 18, that is 1 by 6. So C equivalent final will be 6 microfarad. 6 microfarad. I'm so sorry. Okay, 6 microfarad. Now what do they need is, what is the total charge going? Total charge going will be C equivalent overall into overall potential difference. So 6 into 45, I suppose, is 270 microcoulombs. So this is the total charge or net charge. Now this charge will go, so it will come here. So here it will be 270 minus 270. Then this charge, after coming here to 9 microfarad, it needs to divide itself. Now very carefully we will say that here, let's say the charge q naught goes, so here how much will go? Q minus q naught, and potential is same both sides, so you will say q naught upon 6 is equals to, that is 6 microfarad, and this is 12 microfarad. So q naught by 6 will be q minus q naught by 12. So solving, you will get 2 q naught is equals to q minus q naught. So q naught will be q by 3, and q is 270, so q by 3 is 90. So second option is correct. Got it? Force of attraction between the parallel plates capacitor is q square by 2a epsilon naught. Remember this. This is very simple. Where is the electric field? Let me draw it properly. One, x. This is x. This is y axis. This is x axis, and this is z axis, right? And the electric lines of forces are like this: 5 I cap and 2j cap, right? And where is the area? Yz, like this. This is the area. Now you tell me, if this is your y-axis, this is your x-axis, this is your z-axis, and this is your area, so definitely this 2j cap is not passing through the area, it is not creating any flux. So flux is created only through 5 I cap. So what is the area? Area is 2 meters square. So what is flux? Flux will be 5 into 2, that is 10. Got it? Otherwise what you can do is, area vector you can write it like this. You can say, sir, area vector will be 2 I cap. What is electric field? You will say, sir, it is 5 I cap plus 2 j cap. So what is flux? You can say vector E dot vector A. Got it? Then also you will get answer 10, right? The coefficient of apparent expansion of a liquid is gamma apparent is determined by two different vessels. Okay, gamma apparent is always gamma of the liquid minus gamma of the container, right? First case, second case, gamma of the liquid minus gamma of the container. So this is given 2 delta n delta, right? Okay, so we will say that on subtracting equation 2 from equation 1 will be equation 1 minus equation 2 will become, gamma L will be gone, so it will be gamma B minus gamma A is equals to delta, right? Now gamma B is not given. Acha, they want the coefficient of linear expansion of, okay, so 3 times alpha B minus 3 times alpha A is equals to delta. So alpha b is delta by 3 plus alpha a. Now alpha a is alpha given, so it will be delta by 3 plus alpha. Third option is correct. Got it? This is interesting. If the coefficient of real expansion is 1% more than the coefficient of apparent expansion, 1% more means it is 1 plus 1 by 100 times gamma apparent. That is 101 upon 100 times gamma apparent. So what is gamma apparent? It is 100 upon 101 times gamma real. So this is your equation number 1. What else they need? Linear expansion. If the coefficient of real expansion is 1% more than the coefficient of apparent expansion, then the linear expansion coefficient of the material is linear expansion coefficient of the material of the container is C. Gamma apparent is always gamma real minus gamma of the container, right? So gamma of the container is gamma real minus gamma apparent. So this is 3 times alpha of the container, gamma real minus gamma apparent. So you will say alpha C will be gamma real minus gamma apparent. Gamma real minus gamma apparent upon 3. Gamma real minus gamma apparent upon 3. Now you can put the values, right? Yes or no? So what is gamma real? 101 upon 100. What is, but in terms of gamma real you have to answer, no? So it is gamma real minus gamma apparent is what? 100 upon 101 times gamma real upon 3. So it is gamma real upon, oh god, gamma real upon 303. Third option is, first option is correct. On heating, see, mass expelled upon mass remaining into 1 by delta T will be equals to gamma apparent. Simple concept. So delta M is 1 by 100, 1 by 100 into delta T is 80 is gamma apparent. Solve it, you will get the answer. Clear everyone? So this is all about the solutions of all the 50 questions of this paper. I hope these solutions or these explanations must have helped you in revising these concepts and chapters. Thank you so much and all the best for your next examination.